So we have deployed the Bookinfo application in both cluster 1 and cluster 2, and we right now access the ingress gateway of cluster 1, and we get the product page running on cluster 1. And we created a virtual gateway and a route table to expose the application. What we are going to do now, we are going to update this virtual gateway so that it doesn't select only the ingress gateway of cluster 1, but also select the ingress gateway of the second cluster. And we are going to define what we call a virtual destination. So it's a way to group together multiple services that can run on multiple clusters. So here we are going to define a new host name called productpage.global, which is going to be composed of all the product page services that are running in the Bookinfo frontend in any cluster, because we didn't define any cluster. So if I create this virtual destination, I can then go into the Gloo Platform UI, and if I look at the details of my virtual destination, I can see that I have like two services that have been discovered, one on cluster 1 and the other one running on cluster 2. What I can do next is that I can update my route table, and instead of routing the traffic to the local product page service, I want to route the traffic to the virtual destination I have just created. So when I do that, what's going to happen is that by default it will do like a round robin. So if I continue to access my application here, sometime I will go to cluster 1, and sometime I will get response from cluster 2. The other thing I can do now as well is I can access the applications through the other cluster, because as I said, I updated my virtual gateway. So now if I go to the IP of my ingress gateway of the second cluster, again, I can access my application either cluster 1 or cluster 2, right? So let's go back to this ingress gateway on the first cluster. We can also see what's happening if we look at the graph. So this is the graph that shows the product page service. We can change the settings to say I want to grab by cluster, and right now we see the different metrics that are collected, and we already see the ingress gateway of cluster 1 sending request to the product page in the Bookinfo frontend namespace on cluster 1, and we see then the product page talking to the reviews and details, and reviews talking to ratings, and we can see now the second clusters being displayed as well. So we can see here we also have the ingress gateway of the second cluster talking to the product page service, and so on, right? So we can really see the full picture of what's going on and showing what we have just done here. So as I said, right now it's just a round robin, which is not really what people would expect. You know, that's generally, if you have the service running on both clusters, then you want to just use the local service first. So we can do that easily by defining a failover policy and an outlier detection policy. Again, we can attach these policies based on labels. So we're going to apply the failover policy to the virtual destination based on this label. We didn't put the label yet, so we will have to update the virtual destination, and we say we want to use locality to define the failover. So by default it will try to find a local service. If it cannot, it will try to find in the same zone. If it cannot, in the same region, and so on. But we can be more explicit. If you have one cluster in US East, one in US West, and one in Europe, then if US East is not responding, you want to go to US West first before you go to Europe, for example. So you can be very fine-grained here. And you also need to define when do you want to failover, and this is done with this outlier detection policy, where you say, when I have two errors in an interval of 5 seconds, I want to failover during 30 seconds. And then I want to try again, see if it's fixed, and if it's not, then failover again, and so on. So I just need to create these policies, and after it's done, I can just update my virtual destination to add this failover equal true label, so that my two policies are correctly attached to my virtual destination. And now magically what I can see here is that it's going to always use the version on cluster 1 when I go to this cluster 1 IP, and you will see the same, like if I go to the ingress gateway of cluster 2, it will always go to cluster 2, right? Because both services are running right now. So imagine kind of like what's happening now, right? Request going from cluster 1 go to cluster 1 and so on is through the gateway right now, but everything I described here is exactly the same. If like there is another service like this in-mesh service wants to access the product page, it can use this product page as global name, and it will get exactly the same behavior that we show here in the gateway. Now imagine we scale down the product page on the first cluster. So we just like do it here, so it's not going to run anymore in cluster 1. And if I look at this, will be happening like that, right? So there is no service running locally, so automatically if I go to the ingress gateway of the first cluster, which is this IP, automatically I get access to the one on cluster 2. So that shows one use case, which is like mobility. I can decide that now the service is running in this cluster, I want to move it in the other cluster. If the gateway or if a consumer is sending the request to the service, the standard service, then I need to inform the consumer, or I need to modify the configuration of the gateway to now send the request somewhere else. With this virtual destination, I don't need to do that at all, right? It's going to be automatic. Like, it doesn't impact the consumer when the producer decide to move a service. It can also be used if you want to move out of a platform, from one Kubernetes provider to another, or from one cloud to another. So it can, it has a lot of interesting use cases. So let me have this application running again in cluster 1, and automatically you will see that I will start to get all the requests sent to cluster 1 again. And if I want to show something different, which is like, okay, the service is running but it's not going to respond. So you remember I said after 2 errors it's going to automatically fail over, and you can see that if instead of scaling down, I replace the command of this application, I remove this command, so that basically it's not going to respond anymore. So it's still running, but it's just like not going to be responding to any request. And if I go there here, I just need to wait for that to be finished. Okay, so let me check there. So I patch the deployment here. Did I do it correctly? I think so. Oh no, I did too fast, right? So I need to patch by not removing the command, but I need to patch by changing the command and replacing the command by the sleep. So when I do this, then it's going to not reply anymore. And if I refresh, automatically I go to cluster 2. And as a user, I am not even impacted, because what's happening is that I said I want to fail over after 2 requests that fails, but the default retry in Istio is 3 retries. So it tries once, fails, tries twice, failed, and the third time it's already failed over and goes to the right cluster. So let me just now do what I did before, which is like applying again, removing this new command I have added, so that it responds again, and you will see that it will fall back automatically. After 30 seconds, I'm going to use the cluster 1 again, right? So very powerful. And what's interesting is to understand also that we do that differently than the native multi-cluster in Istio, where normally you need to give like a secret for each control plane to be able to access the Kubernetes API server of all the other clusters, which is not ideal in terms of scalability. You can see for just 4 clusters the number of communications involved, but also not very secure that, you know, if someone compromises a cluster, then you can access the other clusters. Remember that in our case we have these agents that discover the services and that are passing this information to the management cluster, and the management cluster is going to tell the agent what objects to create to make the configuration working properly. And what is happening in that case when we have this cross-cluster configuration is that there are like multiple objects that are created. So one that is called like a service entry. So you see this service entry that's called product page.global, which is going first of all to validate that the service that responds is really the product page and not another service, and also is going to select either the local workloads using this app product page. So that's why we were seeing this round robin between the first and the first cluster, like the local and the remote cluster. So the local cluster is selected here by this workload selector, and it's also select a workload entry that is created that also has this label, so it's going to be selected as well, that give the IP address of the east-west gateway of cluster 2, right? So if I go to cluster 2 and I look at these IP addresses, I can see this is the one of the east-west gateway. On cluster 2 you have also a gateway object that is defined and so on, but just to show you that basically everything is translated into the Istio resources. If I would remove like the Gloo components, everything will still work fine, and it's a lot less opaque than the native Istio integration as well, where you don't know what has been discovered. Here you really define the rules telling which services you want to make available across clusters, and you can see them, you can see what is generated using like kubectl.